Good morning, everyone. Welcome to another episode of Xa Talk Show. Today is 2024, January 1st. New Year, Happy New Year, guys. So we are going to code, Advent of Code. We're gonna continue. This is take 3, Advent of Code 2023, day 5 problem. Okay, take 3. So nobody's here. So we did a vote and 8 votes wanted me to code Advent of Code, but now nobody showed up. One concurrent user. Oh God, let me remind everyone. Streaming now, join, okay? Okay, so we're gonna start Advent of Code day 5, okay? So let me show you my keyboard. This is Kinesis 360 wired, not the Pro version, okay? And this is Ultimate Hacking Keyboard, okay? And let me switch to my desktop so you can see, and let me talk about keyboard for 2 minutes, okay? Those people, so if you are here, say hi, okay? You voted to want me to watch the Advent of Code, but you are not here. That's no good. So keyboard, I did a lot update, the Glove 80 keyboard, a lot update on my review, and also Glove 80's carrying case. I showed this in my past few live stream, 2 of them. So this is actually part of Glove 80 now. So if you buy Glove 80 keyboard, this nice, specially designed carrying case come with it free. Okay, so that's fantastic. Glove 80. Thanks to Mo who gave me one. So Glove 80 keyboard, and you can and Kinesis 360 keyboard. Okay, I also have a review, but I'm gonna update that article and I'm gonna do a new one. So so you can check out my website for the greatest ergonomic keyboard, which one you should get, which one is the best, and so on. I have tons of info there. Okay, so now let's start Advent of Code day 5. Okay, what is this? Okay, let's just begin it. Okay, Xa keyboard block, close. What is this page? Okay, so day 5. Hello, Thiago from Brazil, I think. So day 5. Okay, we did 2 of them, like 5 hours, and failed even passing the first one. Oh shit! So day 5 problem is that you got a text input like that. Let's see, double check, last double check, video check, audio check, yes. Okay, day 5 now. Continuation of drink driving. Drink driving the code for the occasion. Happy New Year's. So you can sell me your Ultimate Hacking Keyboard 1. Yes, I can. Yeah, I have the Ultimate Hacking Keyboard 1. So get on Xali Discord, okay? You can find my Discord on xali.info. There's an invite link. So get on there and talk to me, okay? Good night, Jorman. Jorman, where are you from? This is red wine plus orange juice. Okay, Happy New Year, dude. Nick Coleman, I think I've seen you before. Shai Hui Gang Tian, hello. So get on Discord if you want to know people, okay? So anyway, it's back to day 5. Day 5 is a problem. The first part is you got this input, a text input, which has 2 parts. One is a bunch of numbers that's called seed. So think of each number as a seed ID, okay? So it's just a number, an integer. Then you got a bunch of maps, okay? Now these maps are like hash table or dictionary, so they turn a number into another. But however, these maps is specified in a special way so that, for example, each map has multiple lines. Each line is 3 numbers, a triplet, okay? And so what does the 3 number mean? It means that, so for example, 58, 98, 2, what does it mean? That means this is so that means you start with 98 and there are 2 of them, so there are 2 of them, meaning 98, 99, okay? That's the source of the map, okay? Then 52 is the destination, okay? So also 2 of them, so you got 50 and 51. So these 3 numbers, the first number is the destination, the target. The second number is the source. The third number is how many items are there. So in this case, it means 98 maps to 50 and 99 maps to 51, okay? So they specify a map in this weird way. And each line, each triplet means the same thing. So for example, here 52, 50, 48, that means there are 48 pairs starting from 50 and 51, 52, and so on, 48 of them. And the destination is 52 and 51, 52, 53, 54, and so on, 48 of them. So you create a bunch of 48 pairs from destination to source, okay? So this is one map. The first map, it's called seed to soil map, seed to soil. Then you have another map, soil to fertilizer, specified in the same way by triplets, arranged by triplets. Then you have another map, and you have several of them. So you have total of like 7 of them. So your job is that you take a seed number, let's say 79, then you go through the first map, you get a different number. Now, by the way, if the number does not appear in this dictionary, then it just you are supposed to return a number itself, okay? So you go through the first map, you get a different number, possibly a different number. Then you take that number, you input into the second map, you possibly get another number. Then you do that again, until at the end you get a number, possibly the same as the original, but anyway, you get a number. So you do this for each of the number in the seeds. Then out of all the numbers, you find the minimum, the smallest one of them. That is the answer to the solution, okay? So we started to code that in 2 live streams, and I failed. Because the first live stream, we passed you see, what's interesting is, let me just repeat, okay? For those of you who haven't watched before, let me just repeat what has been done. So in the first video, I finished the problem, the toy problem, no problem, trivial, okay? But however, the user's input, do we have the user input? Yeah. So you see, the user input is this, these hundreds, and each number of items is 100 millions. So when I did this one, my machine ran out of memory. Because for each of these triplet, I'm generating 100 million items. Very inefficient. Because I thought I'm just quickly gonna solve the problem, but instead, this is when you actually need to look into efficiency, okay? Because each of these array is 100 million items, then you have like almost 30 of them. So out of memory. George, thank you. Happy New Year. So big gift. Thank you, George. Ching ching. Fantastic. So So yeah, so and so we want to, so the first day, let's run the code. Okay, so actually let me start to code it and run it so you can see. Okay, so the first day, yeah, let's go to it. Let's start coding. On the pink window you can see all my command. I'm using Emacs, and all the commands I call will show up there, and also you can see the keystroke I call on the left side. So let's magnify it. Okay, so for example, next line of block, you can see the command is there, and let's say delete this block, you can see the command is start delete current text block. Okay, now undo, you can see it is undo. Okay, so I'm using soft-like keys and Vorak keyboard. Okay, now begin the code. Okay, so what is this? So I want to show you, yeah, so I actually need to do a lot cleanup. We are going to do, okay, so let me just start to do it. This huge map, let's not use them. Okay, so actually put it back, and we have another one. Okay, so God, okay, let me just do something. Okay, input, yeah, let's do that. Copy, close, and okay, I'll show you what's going on in a bit. Okay, yeah, so this code, what? So this code you are looking at, that solves the problem, okay, which include explanation. So here's a code. You can see here is the input, here's a seed number, input is a text file. Then all we do is that we did you parse it? No. So wait. So actually, hold on a second. What? Oh yeah, we need this. So we manually turned this text input into the Wolfram format. So let's grab that. Yeah, let's grab that, close that, and go back here. Put it here. Okay, so now copy all, select all, paste. So you can see here is the text input. Okay, but we didn't parse it. Because advanced code doesn't require to. So instead, I just manually created these maps of a triplet. Okay, so then we turn each triplet into an actual dictionary or hash table map. Okay, then this last line basically gives you the solution. Okay, so let's run the whole thing. So run it. So you can see the original seed number, the seed number 79, 14, 55, 13 becomes this sequence 82, 43, 86, 35. Okay, and you go back to the advent of code day 5, the toy input, you can see our solution works 82, 43, 86, 35. Okay, but if you run this on actual, the user's input, where you have millions of 100 million items, then out of memory that's spectacular because Wolfram is running, take all the memory. I have 16 gigabyte of RAM. It suck it up right away. Then OBS crashed, so my live stream crashed, and I didn't know, so and crashed twice. Eventually, I looked at what's going on. It's because in the real input they sneaked in this 100 millions items of array. So this is when you have to consider efficiency. Because on this day 5, because previous days I was thinking too much. I was thinking of most efficient code and the most elegant code and shortest count of characters. So day 5 I was going like, let's ignore that. Just get the quickest problem, the quickest solution, and bam, stuck. Okay, so I'm just gonna go slow. There's no rush. I'm not gonna, because every time I rush, it's not so good. Good night, Nick. And Colombia. Wow, German Molina is from Colombia. That's in South America, right? Wow, amazing. That's a north part of South America. Okay, so what you gonna do? So we got let's clean up. So we got clean up the code. So here is a solution. Let's annotate it so we got clearly, we know what's going on. So the event code, day 5, part 1, solution works. However, when taking the user input, it ran out of memory because the user input, each triplet is 100 million items. Okay, that is the reason. But otherwise, this code works. This is brute force. Brute force solution is mathematicians' favorite solution. You see, mathematicians don't care how you're gonna get there. They only care if there's a solution or not, theoretically. The rest is your coding monkey's problem. Your coding monkeys dealing with memories or memory, malak, whatever. So anyways, it's not practical. I mean, mathematics is not engineering. Okay, when you code, that's part of engineering. So when you do engineering, you need to be concerned with practicality. You need to be concerned with memory diddling, how much memory. You need to concerned with garbage collection. This word gets, the C and C++ coders excited, and Unix, this type of people, compilers, because they hate garbage collection or they love it, but they have to diddle, like how is it done this way, or sweep and whatever, mark, idiotic fuck. This garbage collection, this kind of thing, it's so mathematicians' concern is theory, computer science or theoretical computer science, okay, cellular automata, lambda calculus, Turing machine, computability, complexity of the algorithm, the big O notation, and algorithms, and combinators, logic, proof theory. Okay, that's what we are concerned about. We are not concerned about C++, pointers, pointer arithmetics, memory diddling, bit manipulation. Like let's do a bit manipulation so it can do 1 + 1 faster. Bit shifting bit fuck. Okay, so anyway, let's not get too angry about this. Okay, so let's so that solution, that's the first solution. Now it works. So I'm 21 minutes in, no problem. Relax, okay? Don't get too angry about this. Relax, and the problem will be solved. Now this is the second try. So that was the first day's attempt. For 2 hours, the system crashed. So the second day, I know better. So you don't want to. So for each of these triplet, which represents two ranges. So one range maps to the other, a range of numbers, consecutive numbers range. So instead of creating a hash table for each one of these triplet, you don't want to do that, because each one of these triplet is 100 million items. So you don't want a hash table for each one of them. Instead, because it turns out this is an idiotic map, because it's a map, all right, but they just map, like 58 maps to, 98 maps to 50, 99 maps to 51. So it's like it's not really any complicated. It's a linear, kind of very linear map. So basically, you just add, the difference. You add the difference between the first number and second number for the rest of it. Okay, so it's not really. So we do not have to build a hash table. All we have to do is to do this. Okay. So what to do? So yeah. So if source begin, and let's say, if source start, if the seed number is between source start and source, wait, why is this source start? Yeah, so if the seed number is basically between the source start number 98 or the source end is source start plus number of items minus 1. So if the seed is between them, then that number gets basically transformed into this difference, C start and destination start. So in other words, destination start minus source start. So 50 plus seed. Okay, so basically destination start minus source start, so 50 minus 98 plus the seed number. That gets you the solution. Okay, so this solves this, taking a number going through one of these triplet. Okay, that the code is that one. It's just here. Okay. But now, there's another problem, because for each of these map, you have not just one range, but you have two. So this gets into a slight complication. There are two questions. First of all, do these two maps overlap or not? Because, if they overlap, so if they overlap, that means there's a conflict. One says 79 should be 80, the other one says 79 should be 100. So which one to take? Do you always follow the second one if there's overlap, or do you just ignore the second one or third one, right? So whether they overlap. And there is another issue is what is the issue? Last time I wrote it out, did I delete it? I think so. I forgot. Shit. What is the other issue? So whether they overlap. The other issue is right. The other issue is that once a number is found in one of these triplet, do you continue to the second triplet? Obviously, no, you don't want, okay? So once you found that number is in one of these triplet, then you don't want to continue, okay, even if they overlap, okay? So that's the thing. So we kind of stuck the other day on that problem. Does Wolfram language has a built-in range type? Yes, of course. So there it is, 3 to 9, okay? So you see 3, 4, 5, 6, 7, 8, 9, and you can say 3 to 9 in increment of 2, okay? You got that? 3, 5, 7, 9. Or you can say 3 to 9 in increment of 1 over 3. There you have it. You got a bunch of fractions, okay? And what about in increment of pi over 4? Symbolic computation, far superior than the Python fuck. What if you want 3 to 30 to 9, but in increment of negative pi over 4? There you have it. Okay. What about decimal? You don't want symbolic, you want decimal numerical solution. So negative pi over 4 dot. So that gives you a bunch of decimal numbers, okay? So range is, in fact, Wolfram has table. Table is far more powerful, okay? I'm not gonna explain, but at this opportunity, let me show you. Go search for XR Wolfram language tutorial, so you can find where to download Wolfram engine for free, so that you can use it on my on a terminal. So for example, let me show you. Okay, you start Wolfram script, then we can do exactly the same thing. Let's copy that. Let's say copy something simpler, okay? Paste it there, paste. Okay, control shift V. Oh wait, right click, okay. There it is, range, okay? So what about this more complicated? Paste. There it is. Okay, so you can get this free. That's Wolfram script. You can find the link from XR Wolfram language tutorial. And you can see my tens of video tutorials in the past. The best ones kind of are collected here. Computer graphics, this one, fantastic. So, anyway. So now, but we are here because I wanted to show you a powerful function that generates arbitrary nested array or nested list, okay? And that is called table. So you look at creating list. There it is. So let's show one example. So this can generate arbitrarily multi-dimensional tables, okay? So for example, okay, let's copy that. Okay, so that's like, this is a 3-dimensional array, and you can percentage sign means the last output. Then you can say tree form, okay? So we can show them as a tree. So there you have it. Okay, or we can show them as matrix form or array. Okay, things like that. Fantastic, Wolfram language. So this table form is extremely powerful. And basically, it is similar to Python's list comprehension, okay? So I have an article on Python tutorial of list comprehension. If you can search it if you don't know what that is. So, but basically this table function in a functional form, this table function is equivalent to Python's list comprehension, okay, or Haskell. Anyway, so that's about range. So what I'm saying is that this table is like more powerful form of the range, because range can only generate flat list, one-dimensional list. Although you can have symbolic, you can have like arbitrary function. Let me show you, okay. You can have, for example, let's say this one, okay. So let's say 3 times f some function f4, okay, 2 9. Can you do it? Actually, I don't think so. Yeah. So anyway, you use table, okay. Range is for flat list, but if you want sometimes 2-dimensional or 3-dimensional or n-dimensional array, you use table, okay, that one. Okay, that's about that. So let's go back to solve the problem. I will finish it, okay, today. I will finish this, at least the part 1, no problem. So let's go. So that's a bit digression. Now let's go back to this problem. So where were we? Yeah, we want to go through each of these map, but as soon as we found that one of the map applies to the input, we exit. We don't want to, go through the first triplet, got a number, then we pass that number to another triplet. No. Okay, so each one of these map, even though they have several triplets, just as soon as one of them applies, you exit. Then you go to the next line. Okay, so last time we were stuck there. So what we want is select. Okay, so we just want the select function. Select. Let me tell you what select does. So in Wolfram language, everything you do is a function call. There's no object, there's no directives, there's no statements, there's no special syntax for loops, for printf, there's no methods, there is no, all the class, object, method, instantiation, whatever, finalize, any fuck like that, okay? In Wolfram language, everything is expression, like 1 + 1, then function, then everything is in this single syntax, nothing else. There's no object, nothing, just call functions, apply it to some expression, you get the output. That's it. That's the entirety of Wolfram language. Okay, no object, something, methods or something. Okay, 7,000 functions out of the box. You don't even need to even import regular expression, import reading a file, import walking a directory. Idiotic fuck, the industrial programmers. So anyway, so select, what it does is that it takes 2 arguments. One is a list of items, then the second part is a function, that's a criteria. So that basically it's like a filter, okay? It's called filter in Python and other languages. In Perl, it's called grep, because then it's analogous to grep certain lines, Anyway, so it's a filter function. So select, then the criteria is, for example, here is a example of select, okay? So let's show it. So select you of this list of list, and the function is, so the input is 79. That's one of the seed number. So what we are doing is that if, so basically we are doing this, if this number is between one of these range, okay, so let's run it. So it returns this range, this triplet. That means this triplet is applicable for this seed number, okay, but not the other one. So this select will help us find, there are many triplets of a given map. It will help us find the first map. Okay, now if it returns more than one, then we just select the first one. If it returns more than one, that means this range overlap. Okay, we just want the first one. Okay, what's the question? Does it have multiple? Francis, hi Francis. Does it have multiple representations of lists so that range calculation are efficient? No. Well, internally. Okay, so basically no. So let me explain that one. So in Python, for example, you have, this is the part I hate, okay? I forgot what is. So let me explain that one. Let me digress. Who else are watching? Say hi, okay? If you don't want me to digress, you gotta say something, okay? Put my name, shout out Ksali, say something. Otherwise, I'm gonna, take it easy and go where we are. But we'll finish the problem, okay? So in Python and many other languages, for example, JavaScript 2, you started to have generators. What the fuck does that mean? Anyway, so in Python, let me show you. So in Python, you have a list, right? Then you have, then you started to have, what they call it, Python. Okay, I need more drink. List methods, let's have a look. Pin to list, insert item, so find item. This is my Python tutorial. Go read it if you don't know. So wait, sorry to derail. No problem. This is what this is what Ksa Talk Show is about. A show of talking. List comprehension. So there it is. That's Python list comprehension. They generate a, what's the word? Iterator. The fucking most idiotic fuck. These industrial programmers, they don't understand the thing. Anyway, so in Python, iterator, the word iterator can mean many things depending on the language, okay? Don't get confused, okay? But in Python, specifically Python, an iterator means you have a list, okay? You have a list-like thing, maybe 1 million items or even 1 billion, but it actually is not there. So it's like only when you need to get the value, then it comes out. So this concept is iterator. So the reason for the existence of this complexity is that, for example, sometimes you want to generate, let's say, you want to do a for loop. You want to generate a range of 1 to 1 billion, and then you want to go through each one item. So before Python 3, you first of all generate a list of 1 billion items. Then you do a enumeration. You go through the iteration. Then you go through each index of this range of billion items, right? But the problem is that you don't actually want the billion items, because when you actually generate a range of billion items, you run out of memory, okay? Or 100 million, right? You run out of memory. So there's this concept of iterator. This is a computer kind of programmer's concept or computer engineering. In other words, this iterator concept is a byproduct of computer engineering, okay? You don't really need it, because mathematically it doesn't mean anything. It's just a list. It's just a way so that for programmer, for implementation, or for compiler to avoid this out of memory problem. So it's an intermediate representation for like lots of items. But you get complexities, of course, because now you have iterators. Then you a list is not list unless you turn it into a list. You got several. In fact, I have a article on that. In Python 3, you map something, it fucked up. You got things like that. Actually, should I show it? I'm starting to get into a rant, but should I show it or not? Yes, of course. Why not? Let's just take the time to show it. Because this is actually, I need to explain this well, because otherwise people will just, they don't understand. They'll just say, oh, of course you need to concerned about memory, what you're talking about. This is not pure mathematics, right? So anyway, so let's go back to xali.info, my website. Then there is a section called Why Python Sucks. Okay, and I did a few live streams about that. And so one of the article I want to mention is related to this iterator thing, because it creates complexity and it creates certain intangible concepts, in a programming language. Okay. Also, list comprehension, there it is. Okay. So Python 3 map with side effect doesn't work if result is not used. Okay. This happened in Python 3 because of the iterators thing. Okay. So in Python 3, map, the function map, now returns an iterator, kind of an abstract list instead of a concrete list. Okay. But now if you use the map function to map a function to a iterator or list that's not a, the function doesn't return any value, it just wants to do side effect, then you got a problem. You see, if you use map with side effect, it doesn't work if you don't use the result. So for example, here's a function. What does this function do? Global A, so it just increase global A and return n plus 1. Okay, then map the function to 111 and print A is 0. Okay, you see, we said global A, we want to increase A by n. Okay, but however, the result is A is 0. A is 0. You see, but it fucked up, So what happens is that the result is contrary to your intention, because this function, we explicitly said we want a global variable A and we want to increment it. A equals to A plus n. Okay, but Python fucked it up. But now if you turn the thing to a list, then it does the increment. You see, so this is one of the result of introducing this iterator thing. Okay. Anyway, that's so the obvious question is, how do you solve this kind of problem if you don't introduce iterators? I cannot tell you now. I forgot what was the proper solution, but I don't think iterator is a thing. Okay, so again, remember, iterator, the meaning of iterator can mean a lot of different things or slightly different things in different languages. So right now we are talking about Python's iterator. Okay, so you got this problem. Okay, so in Wolfram language you don't have that. No, you don't have that. Okay, so, and by the way, this kind of thing also happened in Java. They call it generator. Okay, kind of. Also, I have a tutorial on that, but let me show you in a bit. Okay, so hold on a second. So we went digression into the iterators thing. Okay, let's copy that, put the link here, and let's go back. Yeah. Okay, so we want, okay, let's show JavaScript. Okay, So JavaScript, you have JavaScript in depth. Let's say search for generators. Now JavaScript is even more complex. Okay, JavaScript is even more complex. The way they do this kind of thing, even more extremely complex. Generators. Okay, let's not talk about it. Let's go back to the coding of the Wolfram language. Okay, so to answer your question, the Wolfram language does not have that kind of thing. So it doesn't have, like the Python's iterator. Okay, but I believe they are trying to introduce that idea. I'm kind of against. Yes, I believe they are trying to introduce some kind of generator idea. But however, Wolfram language does have sparse arrays, meaning that, for example, you have a matrix of 1 billion items, but however, vast majority of them is 0. Let's say only 5 spots are actual some number, but this 2 by 2 matrix of 1 billion items, most of them are 0. So that's called sparse array. And that's very often used in linear algebra, in actual engineering, when actual data. So that is supported. So you have that kind of thing. So you don't. So what I mean is that you don't actually create an array with 1 billion entries. Row, column 1,000, column 1,000 rows, but rather you have a special representation for sparse array. You just specify which index is what number. So it can represent sparse array, and you can turn it back to a normal array. But if you do, then you gotta, then you run out of memories, things like that. Okay, so you can search for example, let me show you sparse array. Okay, just search for sparse. So you can, there it is, sparse array. Okay, there it is. Okay, so we kind of digressed a lot. Let's really quickly go back, because we are 50 minutes already, because we are starting to get into a situation that I will not finish it today. So let's get back and let's do it. Okay, so let me get back to it. Where is it? Okay, so I want to solve the problem. Okay, so we show this select, how it works. It's just a filter. Okay, so let me get back to the focus. What do you think about Golang? I love Golang. Read my website. Okay, I talked about a lot, and join XR Discord, because we've been just talking about Golang in yesterday. One big argument. Yeah, so there's a question, how do you deal with infinite iterators? Well, in general, you don't deal with it, okay? You don't deal, so I can't tell you what is my ideal solution right now, because I forgot, I don't remember. So that's what I'm saying. I cannot tell you what I think is the proper approach to the infinite number of items situation. So I don't know, but I don't think it's not the generators and iterators. Okay, now let me get a drink, and I'll be back in 2 minutes and focus finishing the problem. juice, orange juice. Right, wine of a red variety. But anyway, to answer your question, I think Wolfram language, about a few months ago, I saw them, Stephen Wolfram, they do online design. So you can watch them, Wolfram and his team, actually talk about the upcoming features. They actually do online, what he call online CEO. So he's doing the design, discussion in real time. So one of the video I watched is that they are introducing lazy thing, which I don't think it's a good idea, because Wolfram language has always been opposite of all these, all these computer engineering byproduct concepts. Okay, like long int, you have this int long double thing, and or reference, every list, every array is a reference to something. Then when you update, you actually sometimes you are changing the reference, or you array idiotic crap. Okay, Wolfram language is entirely different from that. So I do not know how will happen, if they actually introduce this kind of lazy, the generator and iterator thing. How do I feel about Rust? Any programming language that does memory diddling is shit. Okay, now we are starting to get into, the common questions I've been taught to death in my past 3 years of live stream. So Rust is shit. I recommend Golang. Okay, whenever you are probably many of you guys asking that because they love Rust or C++, C, this type of people, they love Rust because it allows them to diddle with memory. They love that. I don't love that. Okay, any language that does that kind of thing, shit. Okay, finish the problem. So then my wife is home, we're gonna do dinner. So now we select one of the range. So select if, so let me quickly finish. Okay, so we have a function here. What is our function? So how big is this function? Okay, it's just there. So select if. Okay, so we need if. I need to do this quickly. Okay, so if select returns an empty list, then say 3. Okay, then say else say yes. Okay, now let me I need to work on, so this doesn't return empty. So what if it's 799? Okay, 888. Okay, so now it's, so if select none of this range applies, then it returns empty. So empty. Okay, so now we got this if. So we want to apply this to, let's see. Okay, so we need to create a function. So we need to create a function that that go through each one of these. Okay, so we need to create a function. So let's see. Create a function. The function is going to map to each one of them. Okay, so function. Okay, function, and the function actually needs to take a seed too. So yeah, because otherwise how do you get the seed number? So where do we have the seed? Yeah, so we got the seed here. And what is x range? Okay, that x range is the full thing. Okay, so let's keep focus here. Now let's see if this function, now you copy that. Oh, nice format. So you see, this is before, this is after. Takes a trip to the Wolfram front end, which you have to pay to get it. So without the Wolfram front end, I don't have nice formatting. I'm using Wolfram mod, which I wrote, which is free on GitHub. Okay, so you go to this source code. This is a home page, Wolfram mod. It allows you to code Wolfram language in Emacs. What's the benefit? Why do you want to do that? Because then you have all the power of manipulating text in Emacs instead of the Wolfram front end. So that's Wolfram mod. It's free on GitHub. You can grab it. Where's the GitHub link? Yeah, download GitHub. Okay, there. Okay, Wolfram mod, fantastic. Here's the source code in Emacs Lisp, of course. Okay, close it. Now, why do I? Yeah, so, but right now I don't have a feature to reformat the Wolfram language syntax. So instead, I copy it to Wolfram, then copy it back. Then I got this nice. But I can write it. It takes more time. It takes a day to figure out how to do that. Anyway, so this is our function. Now let's use the new formatted one. Now, so this function takes, where does it map to? Okay, let's see, where does that, okay, so here, fold, yes, okay, so we are using, let's see, this fold takes a seed and flatten. No, we don't want to flatten. No, we don't want to flatten because we need to go through you know, any set of triplet, we need to go through one of them, not all of them. So we don't want flatten. Okay, so but we still need fold. Fold is like Python reduce. Okay, I gotta finish this quickly because my wife is waiting for me for dinner. Oh fuck, you cannot see. Fuck. Ah, shit. I just wasted another 10 minutes. When did that happen? Oh, fuck. I gotta really... Let's show timestamps. So, 6:56. Okay, only 5 minutes. Yeah, okay. So anyway, we were talking about Wolfram. So here's Wolfram mod. And here's the download on GitHub, okay, Wolfram mod. So back to, we need to finish the code. So this we don't want, and So the maps, the maps is this seed. I mean these maps. Okay, so maps is the right word. Okay, we don't want that. Okay, so this is just a map. We don't want flatten. Okay, so rid of that. So we map that to seeds. Okay, seeds is a list of seeds numbers. Okay, and instead of this complicated syntax, let me write it in a way one can understand. Okay, so map takes two things. Now this part is seeds. The first thing is a function. Okay, and the function will be actually a seed. Okay, so a seed is the argument, and what you want to do with it, you want to fold. Okay, so yeah, so you want to, yeah, so we have a function here. It takes one argument, a seed. Am I doing good? Yeah. Okay, another sip for health. Ching 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 ching. If you like my stuff, pay me. Okay. Gotta finish this problem. Code. You need the brain to work. Okay. Function. You map this function to the number of seeds. So each time this function gets a seed number. Once you get the seed number, you want to do fold, which is Python or JavaScript reduce. Okay, so you fold takes two or three arguments. The first argument is a function that gets the seed ID we have written here. The first, get the seed ID and the range. Okay, so wait, so you map to the map. So actually this should not be the function. Okay, this be something we need to work on. And the second argument is the fold seed map, right? So you do a fold each time you take a seed, and then you go through the seed to each set of triplet. So you first do this triplet, this set of triplet, then the result is a number, then you take that number, then you go through this another set of triplet, returns a number, then you do repeat to the next set of triplet. Okay, so that is what this fold does. Okay, so the fold takes a seed. Now what is the function? That is the question. What do you want to pass the function? Okay, the function will take two arguments, of course, because fold, so x and y. Okay, so the first is seed. Okay, so let's x seed. Okay, the second one is triplets. Okay, remember there's s because each time you are given a set of triplets, meaning a list of triplets. Okay, and the expression, that's what we need to find out. Okay, so the expression, so let's kind of format it a little bit. Okay, so it's quite tedious to format it. So I really need to find a way so I can press a button in Emacs and have it formatted well. Wolfram language is superb. Let me mention this thing. You see this thing. You see they have special, kind of like Unicode characters. and you can adjust, as you see, as long as you, let's select it, you can adjust the window width in real time, and they will wrap appropriately. They will wrap at the logical unit, semantic unit positions. They will not just cut into arbitrary characters. Okay, so you can see this is the power of Wolfram language, and in contrast to the Unix and Python, this coding industrial coder idiocy, C++. They tell you, please format your code so each line is 17 characters. Fuck. Okay, if we expand this window, you can see this whole thing is one single line. And they can, it's not just this, it can be arbitrary mathematical two-dimensional formula with involving nested radicals or nested fractions, and you have this on the fly, in real time, dynamic formatting. Okay, I have shown a nested fraction or kind of complicated math formula before, but I'm not gonna do it today. So back to finish the problem. Okay, fold. So the fold you want, so you're doing a fold, and the function. So what's the function for fold? Reduce. You take two things, right? A seed and a triplet. And what is the expression? Okay, the expression is what we are doing here. Okay, so kind of like function expression. Okay, we don't need that, so let's take that. Okay, and this for while we don't need, because that's the last time we were trying to do that. So we want this thing. Okay, let's see, where do we put it properly? Okay, so function now takes an expression, and this is the expression. Okay, so this expression, it's a triplet, so we need to format to triplet. Okay, so the seed is here. Okay, and the triplets is that. Okay, I believe actually I solved the problem already. It's all here. Let's double check. So the function, the take while, oh yeah, we forgot the if statement. Where is our if statement? Oh yeah, so if statement. So if, yeah, we forgot the if statement, so we need to put that here somewhere. Okay, so okay, not done yet. Okay, so bear with me. So this this is the triplet. Take the triplet, then if that returns, wait, do we have select? Oh wait, why are we take while? Fuck. Oh, we shouldn't take while, we should use select. Fuck. So this select, this is the triplets. Select from the triplets, and if, okay, select from the triplets. Wait, we're getting confused here. So this function takes a seed and triplets, a bunch of triplets. Okay, and then let's focus on the select. So select from the bunch of triplets, and and this is a seed number. And what are the others? So the others are select from the triplets. Yeah, so this is like a function by itself. So to write this in a simple way, okay, let me show you how to write this in a more easy to understand way. Okay, so kind of like that, okay? So we don't need this. So select takes a triplets, a set of triplets, okay? Then apply this function. What does this function do? This function takes one triplet, okay? Okay, takes one triplet, then check if the seed is in this one triplet. Did I fuck up somewhere? We don't need this, okay? Yeah, so what? Yeah, so select takes two arguments. The first argument is a list of triplets. The second argument is a function, a criteria, kind of to filter out. Okay, and how do we filter out? So if the triplets, let's put this XX, okay? So that is shorter. We don't get confused. This is a function, okay? So this way is easier to understand. So in fact, maybe make it one line. That's okay. So if select that, and only take the first result, okay? Don't, if there's more than one, ignore it. Just take the first one. If it is equal to an empty list, then we say, then what you want to do. If it's empty list, then you return the seed itself, okay? God. Otherwise, wait, what? So you don't need this take while. Remove the complexity, okay? So exceed triplet. So if it is empty, then return the seed itself. What if it's not empty? Well, in that case, you do get destination ID. In that case, you call get destination ID with seed and range. Okay, so exceed and oh, but how do you assign it? But you see, so select function. You need to assign this, okay? So you need to create a variable. God. Because right now you need to get a value of this. Select. So if that equals to that, so you need to get a value of this, okay? So if that is empty, then return the seed by itself. Okay. Yeah, there are so many easy ways. Must be. Gotta finish this. Gotta finish this. What is fold doing here? We don't need the fold. Okay, not too bad. Function a seed. Okay, we don't need this fold thing. Okay, so a function gets one argument, a seed, that's one number. Then you do fold, okay? Then you do fold. You pass it, first of all, a function, okay? Then you pass it a seed, which is a seed, okay? Then you pass it maps. That's right. Maps is a bunch of maps, okay? And within this function, what you're gonna do within this function? Well, within this function, you within what function? Oh, within this function, you then call fold, okay? And fold now takes 3 arguments, okay? So let's see if I can clean up. Let's just press it. Let's see if Wolfram. Oh yeah, Wolfram fucking format so nice, so nice. Okay, so fold, you need a function again, a seed and triplets, okay? And in this function, if select, and I want to, if select by this function returns empty, then it's seed, okay? So fold function triplet, fold function triplets, a function. If it's empty, then the seed. Otherwise, no, that's not what let's not do it this way, okay? We got a better way, because this way is problematic. So actually this is confusing. I don't want to use this syntax, so let's do another thing, syntax. This represents our function, okay? Much shorter. So if select that, the first item, okay? You do that, then what is the gested function? Okay, let's try it. Okay, we have the function. Now get test ID. Now apply 79, and the second part will be let's say that, okay? run it. It works. What if this is empty? Do you get a number? Okay, so we need to kind of fix that. Okay, so get destination ID if x range is equal to empty list, then return seed. Otherwise do this thing. Okay, so copy it. There it is. This is our, you see, nice formatting from Wolfram language. Delete that. Okay, so this is get destination ID. So in now if it's empty, it just returns itself. So now it's better. So now we just go back here. So select that. Okay, cut. We don't even need to test the if here. Okay, so remove that grep. So we simply call this function seed and that. Okay, beautiful. Beautiful. Okay, so remove the if statement. In fact, we are done. Copy it, paste here, copy the code. So we got the beautifully formatted code. We don't need that. We don't need this select test. Okay, so this is our solution. This just to this thing, basically. I'm pretty sure it works. Okay, let's run it. Part for the fuck. Part 2 of that does not exist. Fuck. Okay, let's see where is wrong. Fold, seed, xseed, triplets. Get why is that part 2 of 52, 50, 48 does not exist? Part 2, that's right, we got something here. So select triplets. This should be applied to one of them. Select triplets. So triplets. So why is that select doesn't work? X in triplet fold. Fold will need 2 arguments. Okay, so here is a function. Here is a function that takes 2 arguments for the purpose of fold. Okay, so this is a function that takes 2 arguments for the purpose of fold, and So 2 arguments. So the first argument is the seed. So fold, right? So the triplet, so each time the triplets is a bunch of triplets. So here you select the triplets, and triplets has 3 items, 2, 2, 3. Wait, nowhere is 1 referenced. Somewhere should be 1. No, wait. So 2, 2, 3. So why is that? I don't understand. So exceed. So if that's in between second one is the source beginning, second one source beginning plus the third one is range minus 1. Okay, so that's pretty makes sense. Okay, so this is a function, that's how you select. So and return a maximum of 1 item. Oh yeah, so once you got that, you need to take the first item. Okay, right, I got it. So that's why this is what you want to do. Okay, fuck. God. Select all. Let's select all, paste, restart. Okay, still got a problem. So seeds is a list of numbers, that's right. Maps, that's a set of triplets. Okay, we don't want a table. So what? That's the first one. The second one got 3 numbers. The first one got 2 triplets. Okay, so you don't want table form. You want yeah, okay, maybe that's better. Okay, so the first map 2 triplets, second map 3 triplets, third map 4 triplets, fourth map 2, fifth 3. Okay, anyway, so that is the maps. Okay, then so you map the whole thing to fees. So what is wrong? So that's a seed. Then you fold. Okay, this fold part is where it gets really complicated. So let's try just one of them. So this fold is where it gets really complicated. So this here, the seed is 79. Okay. So something is wrong there. 79 maps fold through the maps. Okay, each time you get triplets, each time you get a set of triplets, and then but you select it. What's wrong with selection? God, this is not good. What is wrong with the selection? Okay, so that returns empty. What if so that returns 1, or it may return empty. Okay, so wait. Oh, so okay, so I got it. So it may return empty. So I got the if check is incorrect. Okay, so this fold function, it may return empty. Select triplet. Okay, select triplet. You don't want to take 1. Because it may return empty. So yeah, part 1 of empty does not exist. That's what happens. So once the result of select is either one item or a empty list. Okay, so all you have to do is you just flatten it. Okay, that's it. I think that's it. I think that's our solution. There it is, 8243, 8635. 8243, 8635. Fantastic. How many people are watching? 4. Okay, pretty bad. And fantastic. Money from George. We solved this problem. Okay, I'm pretty sure this is the solution. Now copy it, go to the trip of Wolfram, then copy it back. So we got nice formatting. Okay, now this is the entirety of our solution. Okay, copy all, select all, paste. Okay, that's it. Run it. Okay, now let's try the user input. Okay, the user input, WolframLang mod. So what is the user's input of code? Oh God, we need to parse it. But last time we did the parsing. Let's not parse it. So let's go back. Let's cheat and let's use this. We already parsed the input. Okay, let's use that. Copy, close that. Now back up, do this again. Now this time just paste that, delete. Okay, copy, select all, paste, run it. Okay, so here is, then you just select minimum. Okay, minimum, mean. Okay, mean. Are you sure? Yeah, I'm sure. Shut the fuck up. There we have code. Paste it, submit. That's the right answer, of course. Okay, that's it for today. Our code is just these 2 lines. I can shorten it. I can make it 1 single line. But anyway, let's forget it. That's it. I'm gonna go to dinner. Happy New Year's to you guys, 2024, and good night. Okay, so back, what? Wait, what happened? Looks like we have a control key stuck. Ah, shit. What? What? I hope I didn't erase our solution. What's going on? Wait. So, live coding, Wolfram research. Yeah, 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 yeah. Yeah, fuck. Oh, okay. The code is here. So make it pretty. Show in browser. There it is, our solution. Thank you guys for watching. Bye bye. Fantastic.